Hi guys, today we're going to be graphing absolute value inequalities. So very similar to what we did last Wednesday and Thursday, where we were graphing inequalities, absolute value functions. But now we're going to add inequalities to it. If you don't remember what inequalities are, I'm going to go over that too. Okay, so we start off with our vertex form, right? This is it. You saw it last week, where we have three variables that are going to be replaced by numbers, okay? Where the number in front is referred to the a, the one inside the absolute value signs is the h, and the one outside of it is the k. The h is going to be the opposite value inside, so if it's a minus h, it's a positive h in the vertex, which is the x coordinate of the vertex, and then the k is going to be exactly the same. That one you don't change. Okay. Then the A is going to be giving us a lot of information, so watch out with that. If it's a positive A, it's going to open upward, meaning it looks like a B. If it's a negative A, it's going to open downward. It's also called reflecting over the x-axis, and it's called a negative function. All right, if A, again, the same A, we're still talking about the same A, it's a fraction, whether it's positive or negative, if it's a fraction between 0 and 1, then it's going to be wider or a vertical compression. If that same A is greater than 1, then it's going to create a more narrow function, and that's called a vertical stretch, meaning it's going to look skinnier, right? Okay. The next variable we're going to be looking at is the h. Remember, that's the one inside the absolute value signs. If you're adding an h, it's going to shift left. If you're subtracting an h, it's going to be moving right, or a number, not h, but a number inside the absolute value signs, it moves left if you add, right if you subtract. Okay, and then the last number there, or term we're going to be referring to, variable, is that k. That k, if you have a plus k or a plus, then it's going to shift up. If you have a minus, then it's going to shift down. Okay. The next part is what we haven't gone over yet, but you have seen it before in Algebra 1, where you have inequality signs. This first inequality sign is a greater than or equal to sign. Now, you know it's the greater than sign because you always are going to read from the variable y. So we would have y on the left side, and then the rest of our equation on the right side here. And it's opening to the y, so y is bigger. So it's saying y is greater than the rest of the equation. So when you see the greater than or equal to, this is the greater than or equal to, then it's going to be a solid line when you graph it. And you're going to be shading above that function. And it makes sense because it is greater than, right? Greater than would be above. Now, if you have this next sign here, this is called the less than or equal to sign. Then it's going to be no longer shade above, but shade below. But still a solid line because it has the equal to. Okay, solid line because it has the equal to, but since now it's the less than sign, we're going to shade below. Then we have the greater than sign, which is just greater. If it does not have the little line underneath, then it's not greater than or equal to. So it's just greater than, so it's a dashed line because it's not including any of the values in there, in the line. So you just have a dashed line, and it's still greater than, so you shade above. Alright, and lastly here we have y is less than, so it is still a dashed line. So in the origin, we start here, and then we go down 2, And then we have a +1 inside. That's going to move it to the left 1. And see how we go left 1 and there's our vertex. Okay? So that's how you could get your vertex. And that's just what we did last week. Today we're adding the inequality signs. So this says y is greater than that same function, but now we're greater than or equal to. So when it's greater than, we said we shade above that line, and if it has the equal to, which it does, then it should be a solid line when we graph it. On this next one, now we change it to a less than sign. Well, the less than means we shade below that line or absolute values that we had graphed, but now it doesn't have the equal to, so it's just dashed lines when you graph it, just dashes, meaning that there's no solution or no point that would make it true if it was on the line. It wouldn't make this inequality true. But in this middle one, any point on the line would make it true, and any point inside the shaded area would make it true. Same thing over here, any point in the shaded area would make it true or would be a solution. Alright, so let's do a couple examples. This first one right here, we have this +3, which is going to move it up 3 from the vertex. So 1, 2, 3 from our origin, right? So now this is where we're at, right top, my vertex. Now my slope, or excuse me, I don't want to call it slope because it's closest together, put it on through 1. There's no vertical stretch or vertical compression. So it's going up 1 over 1 on the right. Let me change the colors. And on the left, just like our parent function. Because it is less than, right, that sign we read from the y, it is less than or equal to, then it is a solid line because of the equal to, and less than means I'm going to shade below. Okay? Now I want to check that I shaded the correct way or the correct side of this. So we're going to use the test point. The easiest test point would be here at 0, 0. So I'm just going to pick a point, any point, but really the easiest one is 0, 0. So my test point is going to be 0, 0. What I'm going to do with this point, I'm going to get this equation over here, this inequality, excuse me, and in place of x, I'm going to put a 0, and in place of y, I'm going to substitute a 0. So here I'm going to have 0 is less than or equal to the absolute value of, again, 0, because we're using the same test point there. And then I'm going to see if it makes it true. Well, the absolute value of 0 here on the right is 0 plus 3 would just be 3. Then I'm going to read this. It says 0 is less than or equal to 3. Then is 0 less than or equal to 3? Excuse me. Yes, it is. So this is true. So then we know that we should shade in that direction because that is the solution to this inequality. So this would make it true. So yes, we shaded in the correct spot. Alright, next one. This has a +2 at the end. So from the origin, we're going to move up 2. Then you have a -1 inside, and we know -1 moves it to the right 1. And if you're not sure, you can go back up to your notes and look at that. So up 2 over 1 from the origin. Then I have them, again, there's no number in front here. So there's no a other than 1. So it doesn't change our rate. We're still going up 1 over 1, up 1 over 1 to the right and to the left. Because there's no vertical stretch or no vertical compression. Ooh, and I already started drawing, but that's wrong. This is the less than sign. So less than has to be a dash because it doesn't have the equal to. And excuse my horrible graph. And then shade below. Because that's, oh my gosh, I don't know why I just said less than. It is obviously the greater than, and I hope I didn't confuse the heck out of you. It is a greater than sign, so we shade above. Wow. Remember, it's like a little crocodile mouth. It's opening to the y, so it is eating the y, so y is greater than the rest. Okay, so we want to use a test point. You can use one inside or one outside. Just to see, I'm just going to use this one right here. That is 0, 5. So my test point here, my TP, is 0, 5. And I'm going to plug it in place of the y in the equation, inequality, and in place of the x, I'm going to plug in, a 0 in place of x and a 5 in place of y. So 0, no, sorry, this is my x and this is my y. So that's 5 greater than the absolute value of 0 minus 1 plus 2. When we do the math inside, 0 minus 1 is negative 1. The absolute value of negative 1 is positive 1 plus 2 would be 3. And then is 5 greater than 3? Yes, it is. So we should be shading towards that point because this makes it true. This is a true statement. Alright, next example. We have a minus 3. So we know that from the origin we move down 3. So my vertex will be here. There's no number inside the absolute value signs with the x, just x. So then my h would be 0, or you just don't move left or right. You're just there on the x, on the y-axis at this y-x value for 0. 0 for the x value. Sorry. Okay. And then the next thing there is we have a vertical stretch because of that too. You can also think of it almost like your slope if you had a linear equation. So you're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. On the left side, up 2 over 1, up 2 over 1. And that's our vertical stretch. Oops, kind of missed it there a little bit. Alright, and then this is a less than or equal to because of that line. And sorry, I cannot write very well on here. So that's going to be a solid line. So solid line. And then the less than means the shade below. Then you want to use a test point, preferably one that's already in the shaded area, and see if it makes it true. So I'm just going to use this point right here, 3, 0. So 3, 0 is going to be my test point. This is going to be my x coordinate, my y coordinate. I'm going to plug it into the inequality here. Y is less than or equal to 2, absolute value of x minus 3. Plug in my point, 0 and 3 in place of x and y. And then do the math. The absolute value of 3 is 3. And then we have 2 times 3, which will be 6. And then subtract the 3, so 3. And then we read it, bring down the 0 on the inequality side. Is 0 less than or equal to 3? Yes, it is. So this is a true statement. So then we shade it the correct way. Alright. This one, when it's not like our example 3 where we don't have a y, I can still graph it, but I need to put all the numbers on the same side. So I have to subtract a 4. If I subtract a 4 on one side, I subtract a 4 on the other. But it has to be outside. Or it doesn't want to let me write my inequality sign. So it's going to be minus 4 like that. And 0, 4 minus 4 is 0. So I'm left with this. All the numbers are on the same side. So now I can graph it. And you see that it's going to be minus 4. So it's going to go down 4. And then there's a plus 3 inside. So that means it's going to move to the left 3. And then there's no a. So again, it's just a regular one. So it goes up 1 over 1. And then check it out. We went down 4 from the origin, 1, 2, 3, 4, and then 1, 2, 3 to the left, and there it is. And then it's going up 1 over 1 to both sides because our A, there's no vertical stretch or vertical compression, it's just 1. Okay, let me show you something real quick. This equation here, we could actually solve it, right? It's set equal to 4, so I could actually split it to equal to 4 and then to equal to a negative 4. If I solve for x, like we did in yesterday's assignment, subtract a 3, subtract a 3. then x equals, and I'm sorry, this doesn't look pretty, 1. Then subtract 3, subtract 3, x equals negative 7. But check out what that looks like in our graph. When we find the solution, here is x equals 1, and here is x equals negative 7. They're actually my x-intercepts, and if you remember from Algebra 1 quadratic functions, they're also called roots, they're also called zeros, they're also called solutions. But the easiest way to remember is x-intercepts. So just a little review there of what that means. Okay, this one right here, very similar to the last example, but it's set equal to a negative 4. So, if I actually wanted to solve it, I couldn't. So it's not possible to solve, but I can graph it for sure. I'm not even sure I spelled that right. Remember, if I want to graph it, I have to move it to the other side, all my numbers. So I have 4, so I have x plus 3, and then outside of plus 1. Once it's set equal to 0, since there's no y, as long as it's set equal to 0, then I can graph it. So this plus 4 means I'm going to up 4, and then the plus 3 inside still moves it to the left, right? So plus 4 moves it up from the origin, so we go 1, 2, 3, 4, and then 1, 2, 3 to the left. Again, there's no a, so our a is just 1, so you go up 1 over 1 to both sides, left to right. And you notice this actually doesn't cross the x-axis, so it doesn't have any solutions. And we know that because over here it was set equal to a negative 4, and we didn't have any possible answers, so there was no solutions. Why? Because when you graph it, it doesn't cross the x-axis. Alright, and that is it. Those are all our examples. For your assignment, you definitely want to look at these first examples. And this first page here is your best friend. So make sure you have your notes out, and please look at them while you have your assignment, while you're doing your assignment.